Hi there, my name is Dmitry and I'm the host of the show 16 Bits Ago, which is out on the separate channel and is made for Russian-speaking audience. I am telling about old computers, mostly home computers like Atari and Commodore. I am doing this show on a weekly basis because actually these computers were not so popular in Russia, and current generation of people who are interested in IT don't even know about these computers. So I am trying to inform them about it, and this show has now 50 episodes, and my final episode, it's not final, it's just the last for now, was about a Soviet old computer, which is also maybe not known to some people here, even in Russia, and of course it is hardly ever was known somewhere outside USSR. So I've decided to make this one particular episode in English, so that all the other countries could also watch about our Soviet home computer, which is, I guess, pretty uncommon, but it is an interesting piece of equipment, so I've decided that some of you may find it interesting. So let's see what I'm talking about.
In 1985, economy of Soviet Union included the production of home computers into its plan, because the need in them appeared in USSR just like in the rest of the world. In my show, I talk a lot about Soviet technology being cloned from often obsolete Western devices, so I am frequently being told to stop blackening Soviet reality. But I want to assure the viewers that I don't have any prejudice about USSR whatsoever, and I admit that our Soviet engineers did a great job because, first of all, we did have our own developments, and second, it's not easy to create even a clone of a microprocessor without any blueprints, etc. Furthermore, USSR was not the only country cloning successful Western processors. This was quite a common thing, and Soviet clones were one of the best made. Still, this my telling is based on a technology that doesn't have any direct analogs. In Soviet Union there was an absolutely independently developed chipset called K587, based on an architecture created in so-called Scientific Center in Zelenograd near Moscow. This facility was established in 1962 by the order of Central Committee of Communist Party of the Soviet Union from August 8, 1962. It was ordered to organize the Center of Microelectronics and a complex of research institutes and construction bureaus in Union republics. This was pretty promising for Soviet industry. USSR was targeting to become an IT giant, and who knows, it could be possible. But the fate has spoken. In 1966, the Scientific Center included 6 research institutes and 5 factories, which was comparable to Intel power of that time. In 1976, there were 39 institutes and factories already. Unfortunately, the work on K587 was suspended due to decision of Ministry of Electronic Industries, because the world was dominated by DEX PDP-11. Soviet architecture was modified, which led to the series of 16-bit single-chip processors 1801VM. It should have become the system-on-chip device, or a microcontroller. K587 even had a name, Electronica NC, and the microcontroller even had a model number, 1801VE1. Because of this change, of course, the architecture Electronica NC was abandoned, and the architecture PDP-11 took its place, so the command system of 1801VE1 repeated the PDP's 11th one. So this looks like we had another Soviet clone, but this microcontroller was a single chip when PDP-11 was a big LSI. Of course, DEC released its single-chip processor DEC-T11, which was repeated as Soviet K1807VM1. Russian industrial microcomputer Electronica 60, powered by this chip, was quite a breakthrough in this matter, because its closest counterpart, LSI-11, didn't have a single-chip processor. In 1981, Scientific Center released 1801 VM1 based computer called DVK-1. This acronym in Russian stands for Dialogue Computing Complex. This computer had 48 kilobytes of RAM and 8 kilobytes of ROM with BASIC and Focal in it. The Focal language is not very popular nowadays, but it actually was pretty popular, high-level language with compilers still included in GNU-C compiler and Microsoft Visual Studio. The code is still compilable on Sun SPARC and x86 compatible processors. There even was a language called Coke, which is, believe it or not, was made at Coca-Cola Company. DVK-1 was able to perform 330,000 of instructions per second, which was pretty good for that time. Its successor, DVK-2, had 56 kilobytes of RAM and two 8-inch floppy drives, GMD 7012. DVK-2M then had 5.25-inch floppy drives to match world standards. DVK-2M's price was 15,600 rubles. The official exchange rate was $1.40 for 1 ruble, so the export price of DVK-2M would be near $21,000. This was huge and totally unaffordable. In 1987, USSR organized the Navy operation codenamed Etrina, resulting in a huge submarine fleet appearing near USA coast. The sonar system of Soviet boats was driven by DVK-2Ms. The DVK-3M had 248 kilobytes of RAM, and DVK-4M had the whole megabyte, inside which a RAM disk could be created. The operating system was called Demos DVK. The acronym in Russian stands for Dialogue Unified Portable Operating System, based on Unix version 7, written in Kurchatov's Nuclear Energy Institute. Meanwhile, there also were another industrial computers in development called SM. This was done in cooperation with all socialist countries: Bulgaria, Hungary, East Germany, Cuba, Poland, Romania and Czechoslovakia. SM1 and SM2 were 16-bit machines compatible with Hewlett-Packard HP 2000. SM3 was compatible with PDP-11. SM1700 was compatible with 32-bit VAX machines, and SM1800 was compatible with Intel x86. Furthermore, if SM1810 worked on 1810 VM86 processor, which was a clone of Intel 8086, the SM1820 worked on the original Intel 8386. Later, SM1820 integrated the Intel Pentium. It was like today's Blade server, where the single SM1820M blade looks just like a compact PCI device. This is pretty cool. But all these computers were industrial equipment, and Communist Party ordered Scientific Center to produce the computers for regular people. This was not much later than 8-bit home computers became popular in the West. By the way, gaming consoles made in the Soviet Union were already popular inside the country. I made the review of Atari Pong console clone made in 1982 in Moscow, but unfortunately it's in Russian only. So, in 1985, the first home computer finally made it to USSR's inner market. BK0010 was created in Precise Technology Research Institute of Scientific Center in Zelenograd. It was developed by engineers Poloskin and Kosenkov. The computer was based on K1801 VM1 processor, compatible with DEC LSI 1103, running on 3 MHz. The computer had 32 kilobytes of RAM, 15.5 kilobytes were available for programs, 512 bytes were reserved for registers, and the other 16 kilobytes were used as a video memory. This is actually pretty big amount of VRAM, so it just begs to write games for it. ROM was 32 kilobytes too. It contains the drivers for keyboard, display and a tape drive. The very simple operating system was in ROM too. The video chip K1801 VP1037 could display 4 colors in resolution of 256 by 256 pixels. There were 2 TV outputs. One was for color TV and the other is for black and white. In black and white mode, the resolution was 512 by 256 pixels. And the text was meant to be read in black and white mode, because actually this video chip cannot display any text mode at all. All the letters are displayed as graphics, and both TV outs work simultaneously in any resolution, and when you use 512 by 256 resolution using color output, the text becomes blurry, yet still readable. To read in color mode, you should switch to 256 by 256 pixel mode, so the text will become more adequate. Just for the comparison, the BK0010 cost only 600 rubles, roughly $840. This was still much more than a salary of a Soviet engineer, but it was considered affordable. Of course, BK0010 was not only made for home use, it was highly spread in schools. In Soviet Russia, there already was a popular IT learning complex made by Yamaha on the MSX technology. So the BK0010 also was used as an IT learning complex. The Basic 86 in BK, also known as Vilnius Basic, had the same error codes as MSX Basic. I guess this was done to not confuse those students who had to study on both machines. The computer class of BKs was controlled by teacher's computer, which was DVK2M with a network interface. It also served as a file storage. In 1989, BK0011 was out. Its processor worked on 4 MHz of frequency. It had 128 kilobytes of RAM. The floppy drive controller was now built into motherboard. There now were 2 pages of video RAM, so the refresh of the screen could be done more smoothly. The video chip still could display only 4 colors, but now it had 16 screen palettes, so the graphic capabilities somewhat grew. Also, when people say they had BK0011, they usually mean 0011M, because 0011 was out in pretty small amounts due to a bug with the sound. The programs written for BK0010 were silent on the 11. In the M model this was fixed. There was another modification which was very rare. It was called BK0100. It had 16-bit processor K1801VM3, and it also had the second processor, which could be KR580VM80A, which was a clone of Intel 8080A, or a 16-bit KR1810VM86, which was a clone of Intel 8086. Of course, there were different kinds of peripherals for this computer. There was a music add-on called Menestrel made for composers. There was a BK printer and even a mouse called Martian Lady, whatever it means. Maybe it was called so because the mouse was huge as Mars and looked like boob. I don't know. Also, this was a time when first semi-private business became allowed in USSR. So many new companies were making third-party add-ons for these computers. Those were audio processor 8938910 by General Instrument. Kovacs speech thing was adopted for this BK. Additional memory modules were produced, a light gun, and even a modem. This is far from being a complete list, and that even doesn't count all the devices made by enthusiasts for non-commercial purposes. Also, this was a birthplace for the first Soviet overclockers, who made this 3 or 4 MHz processor to run on up to 6 MHz, which brought all those problems still common today, like instability and components incompatibility with the higher clock. The computer gained huge success and obtained quite an amount of software. There was even a C language ported for it, so the possibilities were pretty damn high. And of course I cannot forget about games. Officially there were more than 800 of them. Some of them were made in USSR, some were ported from other platforms.
So this is BK for you. I hope it wasn't too boring, and pardon my English, I know it's far from being perfect. But I still hope it was understandable. There are a lot of emulators of BK for x86 compatible computers, so this is pretty easy to experience what BK was. It can be more difficult to find software for you, but there is a Wikipedia article about BK in English, and there are links to emulators. Well, you can Google it, and I think no problems will be there. Well, I guess this is it, so thanks for watching, goodbye.